Okay, another situation. You're driving alongside another car when you begin to accelerate uniformly. 10 seconds later, you're 50 meters ahead. What's your acceleration? Well, we know that for your car, x of t equals x of 0 plus v of 0 times t plus 1/2 a t squared. The other car, we'll call this x1 of t. We'll call it x1 of 0, v1 of 0, 1/2 a1 of t. x2 of t, the position of the other car, is x2 of 0 plus v2 of 0 times t plus 1/2 a2 t squared. This is generally the case for any situation where both cars are accelerating uniformly. In this situation, we're going to let t equal 0. And you begin to accelerate. Remember that there's nothing here that tells you when you have to start the clock. So you can start the clock at the instant you begin accelerating. And these equations wouldn't both hold unless you were both accelerating at the same rate, which doesn't occur until you begin to accelerate. Now, a2 equals 0. Since the other car is at constant velocity. x1 of 0 equals x2 of 0 because you're driving alongside that car when you begin accelerating. Also, v1 of 0 equals v2 of 0 since you were driving alongside the other cars, presumably at the same speed, or you wouldn't be you would be driving alongside the other car. You might be passing the other car, okay, in which case your speeds would be different, but you're not passing the other car, you're driving alongside it. So, we have these two conditions. It then follows that x1 of t equals 1/2 a1 t squared plus v of 0 where we let v of 0 equal v1 of 0, which also equals v2 of 0. And we could also choose to start our measuring stick wherever we want to. Okay, we'd start measuring position from the position of the two cars when you started accelerating. So you can let x1 of 0 equal x2 of 0 equals 0. So x1 of t then would just be 1/2 a1 t squared plus v of 0 again being the constant, or the common velocity. And of course that's v of 0 times t. And x2 of 0, or x2 of t, would just equal v of 0 times t. Okay, I think I said that right. x2 of t is v of 0 times t. Okay, now, what do you know? You know that x1 of 10 seconds minus x2 of 10 seconds equals 50 meters. Your position minus the other car's position, 50 meters. You're 50 meters ahead. Well, we put that into this equation. You have 1/2 A1 times 10 seconds plus V of 0 times 10 seconds minus x2 of t, which is V of 0 times t, so that'd be V of 0 times 10 seconds, equals 50 meters. We just have one unknown acceleration, and everything else subtracts away. I don't like the word cancel. Okay? So you have A1 equals 2 times 50 meters. And I forgot to put the square on this. It's another good reason to write your units. And the units here were going to come out meters per second, which is not a unit of acceleration. So I caught myself in a careless error here. Okay? So, anyhow, this equals 1 meter per second squared. That's your acceleration. Now you could then go on and ask how much faster are you going than the other car. Once you determine this acceleration, it's easy to figure out how much faster you're going. So that you can kind of figure that out. I'll kind of outline it. So if the problem had asked not what is your acceleration, but how much faster are you going after 10 seconds, you would have had to know to use what you have to find the acceleration, and then apply that to find the difference in your velocity. And of course, the difference is going to be 10 meters per second. That's around 23 miles an hour. And if you're anywhere close to the speed limit when you're here, maybe want to slow down a little bit. Okay? So you can maybe try to verify this. Be a good exercise.